Good evening, everybody. What we're doing today is looking at section 2.5 in the book, Reasoning in Algebra and Geometry. What this really is kind of a continued introduction to proofs. So this is what I want you guys to do. If you have your book, I'm just going to work through some of the problems. So proofs are important because, as I said before, they really give us the why of what we're doing. It's like when your parents ask you, what were you thinking? Why were you doing this? It's important to understand why that is. Up until this point, mathematically, many of us have simply done something because we're told to. We have x minus 4 equals 7. Our teacher says, well, we're going to add 4 to both sides. Why? Well, because that's what we do. X equals 11. And then if we want, we can check that. We can go 11 minus 4 equals 7. And then we get 7 equals 7. And that's right. But the problem is that doesn't tell us why we can do that. And so in proofs, really what we're doing is we're going to break down every problem we do step by step. And we're going to say, this is why I did this step. This is why I can do this step. So we're going to do two things today. We're actually going to go over what the goal was in class today, which is the Got It 3 problem. But first, we're going to go over a couple of things that are going to be on the assignment. Now, I know I'm missing a couple people in class today. So the assignment is starting on page 117. I asked you guys to do number 5 through 7. And then you're going to flip the page, and you're going to do numbers 14 through 19. And then finally 25. 25 is an error analysis problem. If you look at that, you see that the first step is A minus B, or A equals B, and that's given, and that's fine. Two things can equal each other. 4 times 3 equals 6 times 2. There's nothing wrong with that. But then we look down at the last step, and we see 1 equals 2. Division property of equality. So what you're going to need to do is figure out where they're wrong. Now, you're going to be a much better place to do that if you go ahead and you work through some of the earlier problems. Now, all of you guys should have in your notes from last week, as well as Monday when I was gone, it was still up there, that list of properties of both equality and congruence. Now, if you don't have those, they can be found in your book, bottom of page 113, and then through page 114. Make sure you have those. Those are important. We're going to go back to those again and again and again. So let's look at number 5 first. So number 5, we have 1. I'm going to go black. Give me just a second. We have 1/2 x minus 5 equals 10. Now, personally, I would start off by adding 5 to both sides. That's how I do it, but they do it a little bit differently. They multiply both sides by 2. It's called clearing the fraction. Golden rule of algebra, if we do it to one side, we got to do it to the other. And that third step we see is x minus 10 equals 20. And that fourth step we get x equals 30. So what we're going to do here is we know that this is given. And then below we have A, B, C. Now for each of these, it's important to understand what they're looking for here. So for this first one, they're looking for how we got from step 1 to step 2. So we look at it and we go, well, what changed? And what changed was we multiplied both sides by 2. So now what you need to do is you need to head back to page 113. You need to look through those properties and you need to say, hey, which one of these says that if I multiply one side by something, this 2 right here, then I can multiply the other side by the same number and keep this equal sign. And that would be the multiplication property of equality. Multiplication property of equality. Now the multiplication of property of equality, simply put, is this. If A equals B, then A times C equals B times C. As long as you multiply both sides by the same number, you get to keep that equal sign. So number 2, here we're looking for, again, it's important to understand how we got from this step to this step. What changed? Well, what changed is we did the multiplication, but more importantly, we multiplied everything inside that parentheses by the 2. And everyone should know, this pops up all the time, that is the distributive property. Distributive property. So that gives us our final step. How do we get from here to there? That's easy. We add 10 to both sides. So just like when we multiplied 2 to both sides was the multiplication property of equality, this one's a real brain teaser. It is the addition property of equality. Oops. And that's our proof. That's number 5. Because what we're doing is these are the steps we take. Okay, and those are the same steps you'd take regardless of whether you knew why you were doing it or not. And it's important to realize that the algebra doesn't change. That the reason that you're doing this is the same reasons you've been doing it all along. That you want to, as a mathematician, solving an algebraic problem, you want to isolate that variable. You do that by combining like terms, by applying inverse operations, and doing that until you have x on one side, or your variable on one side, and a constant on the other. All we're doing now, that's the same. You've been doing that all year long last year in algebra. What we're doing now is this. Everything I just highlighted red. That is the proof. We're taking it a step beyond. We're saying, you know what, we're not 4th graders anymore. It's no longer good enough to just sit there and accept the fact that our teacher said to do this. What's the rule that lets us do this? We're going to think for ourselves. We're going to make these decisions for ourselves, and we're going to see whether or not we can justify the steps we're taking. And that's how that works. Now, in class, a lot of people had trouble with number 7. So we're actually going to go through that as well. Okay, so 7, there are 2 parts to. There is, I'm going to draw a little sketch on one side. And we have an x right there. Over here we have 3x plus 20, because, of course, both of those are degrees. And we have E, it's an E, C, D is our vertex right there, and over here is F. And of course all of these are rays, so let's put those little extra arrows on. And that's that. So we know that they form a linear pair. And so there's that little thing S, that right there, just so you know, that is how you write angles in shorthand. Remember, the L goes before the E, otherwise you're talking about angels. So, and then it says angles that's a T, so we'll read that. That form a linear pair are supplementary. So angles that form a linear pair are supplementary. So it's important, we're going to be flipping back and forth between this really quickly. But we're going to start off with angle CDE and EDF are supplementary. And that, what we wrote before, is kind of our justification. So now we're going to start off and we're going to say, step 1. the measure of angle CDE plus the measure of angle EDF equals 180. So let's look back at the picture. We see that CDE is right here, C to D to E, plus E to D to F equals 180. And that makes sense because they're a linear pair right there. And angles that form linear pairs are supplementary. What are supplementary angles? Well, two angles equal 180 degrees. Their sum is 180 degrees, and they're supplementary. So we're going to put as our reasoning there, we're going to put the definition of supplementary angles. So then step 2, we look at what they did. And we go, okay, step 2, they rewrote this like this. X plus 3x plus 20 equals 180. So let's get back there. Well, we see that this is x, and that's 3x plus 20. So if we needed to write that out, we would write the measure of angle CDE equals x degrees, and the measure of angle EDF is 3x plus 20 degrees. So that is simply B right there. And that's just going to be substitution. Everyone say hi, Shima. That's my son's cat you hear in the background. Number 3. So now we're going to go from there and we're going to go to 4x plus 20 equals 180. Now this may seem counterintuitive a little bit, but whenever we have parentheses without a number there, we assume that there is a number 1 in front of it. So what we actually did there was we distributed that 1 and then we combined like terms. So we're going to actually call C distributive property again. And then you guys should be able to finish this out by yourself. Next, we're going to go 4x equals 160. Well, what did we do to get from this step to here? And that's what we're going to put for D. Well, we subtracted 20 from both sides. So that's our good friend, subtraction property of equality. Then 5, we get x equals 40. And again, what we're looking here for E is we're looking for how we got from step 4 to step 5. Well, we divided both sides by 4, just like that. Having a little bit of an issue with the zoom, sorry about that. And so that would be the division property of equality, or equality, as most people say. So that was number 7. So now we've done 5 and 7. Just really quickly want to go over number 14 through 19. Basically, if you're looking at this, all you have to do is, so number 14, it says the symmetric property of equality. So if AB, remember, there's nothing above it, so we're talking distance there, equals YU, then, and it leaves us a blank. Well, the symmetric property of equality says that if A equals B, then B equals A. See the symmetry there? Equal on both sides. Wow. So we're going to write it like this, YU equals AB. So that's what you do for each of those, 14 through 19. All you do is go ahead and fill in those blanks with what it says. If you need a hint on 25, go ahead and email me or just ask me in class, and I'll try and walk you through it. So finally, that gives us to our goal for the day. Our goal for the day was, if we're looking at this line here, A, B, C, D, and if we know that the distance from A to B is equal to the distance from C to D, so that's our given, then we need to prove that line segment AC is congruent to line segment BD. So I want you to, we're going to do this a little bit differently than the book teaches it. The book teaches you to go kind of step by step, and this is what I want you to do. I want you to be able to sit there, look at this, and talk your way through it. Okay? So this is what I'm going to do. I'm going to say, okay, I'm going to start off step 1 and say, I know that AB is equal to CD. Okay, I know that. Why? Because it's given, plus there are those little hash marks there. Everything nice and easy. So I know that these two are the same. So I'm going to draw one in green, and let's go purple today, and one in purple. So I know that those two are the same. I also know that if I'm looking at it, that middle area right here, the one that I just did in blue, well, that's kind of, so I'm going to say that the middle area that I'm just adding the middle to both sides. Because if I'm looking at B to D, notice that what that is that C to D right there plus B to C. Likewise, if I'm looking at A to C right there, see A to C, then that's simply this area right there, A to B, plus B to C. So that would give me my third clue, which is that if the starting lines were the same, and I add the same length to both, I end up with two equal lengths. Now that, ladies and gentlemen, is what we call a paragraph proof. I'm not doing a 2-column proof. I'm simply saying how I know that this has to work. So I know that AB equals CD. I then know I'm adding the middle, that B to C right there. And I'm adding the same length to both sides. And I know that if I start off with the same lengths, and I add the same lengths to both of them, then I'm going to end up with the same lengths. And that's how I know that AC is going to be congruent to BD. So I can look at that and I can talk my way through that. Now, honestly, talking your way through it and knowing what you did is over half the battle. But I'm going to be honest, it's the easier half of the battle. Trickier part comes up next. And the trickier part is when we sit there and now we have to prove it. So I'm going to start off. I'm going to draw my little table here. And over here, I'm going to have my steps. And over here, I'm going to have my justifications. Step 1. I said that AB equals CD. You know what? That's given. That's the only piece of information we were given, right? So next, let's look at what we said next. I'm just adding the middle to both sides. Now, this is a step that most people are going to have difficulty with, and that is the use of the reflexive property. Now, here I'm going to say that I need to put down that BC equals BC. Now, that may seem fairly straightforward, and like everyone's going to go, duh. But it's one of those things because we're adding over here from C to D, we're adding C to B. And from A to B, we're adding B to C. So because we're adding that to both sides, we need to put down that they're equal to each other. Like I said, I know that sounds silly. I know that may seem absolutely worthless at times, but it's necessary. So there we're going to put reflexive. It is the reflexive, or as some people in class were saying, the reflective or the reflection. Now, the reflexive property of equality is what it is actually called. That is the correct name. But if you think about it as the reflection property of equality, though wrong, it helps you because it's kind of like looking in a mirror. A equals A. BC equals BC. The length from B to C equals the length from B to C. So let's look at step number 3. In step number 3, what we're going to do is we're going to add those two together. AB plus BC equals CD plus BC. Now notice what I did here is I just added those up straight down. And I can do that because I know that they are the same length. How do I know they're the same length? Reflexive property. So what allows me to add the same thing to two sides of an equation? Well, that's pretty straightforward. That is the addition property of equality. And then we go number 4. So what do we do now? So we just said we're adding the same thing to the middle to both sides. So we go there. And then we go, if the starting lines were the same and I add the same to both lengths, then I end up with 2 equal lengths. Now that's what I know I'm doing. So, but how do I say that when I look to my final lengths? And what I want to do on each of these is I want to break it apart. So I want to go, I know that AB plus BC is equal to AC. And CD plus BC is equal to C or BD. So I know that, right? And I can look back and that makes sense. And that because I go, if I take this length plus this length, then I'm going to get this length right there. Same is true of the other way. If I go CD plus BD, then that is going to be the same length as B to D. And that, you're going to have to go a couple weeks back, but that is called the segment addition postulate. Okay? Segment addition postulate. When we add two parts of a segment to each other, then that third resulting segment is equal to the sum of the two parts. Again, if I know how far it is living in Cottonwood right now, I know how far it is from Cottonwood to, let's say, Anthem. I know how far it is from Anthem to Happy Valley. That's a straight line, so I know how far it is from Cottonwood to Apple Valley. I just add up those lengths and go from there. Does that make sense? Okay, let's keep going. So now we have our final step. Actually, it's our penultimate step. And we go AC equals BD. Now notice what we did here. We have this step right here, step number 3. And we go AB plus BC equals CD plus BC. Then step number 4 says AB plus BC equals AC. So what we're going to do is we're going to plug that in right there. And then we're going to take this one right here, and we're going to plug it in right there. And that's going to give us this, AC equals BD. And again, good old friend substitution. And finally, we can say that AC, line segment AC, is congruent to line segment BD. Why? Because segments of equal length are congruent. I would also accept just the definition of congruent segments. Two segments are congruent if they have equal lengths. So notice that what we had to do there, because we're looking back at the actual problem, we had to prove not that their lengths were the same, that's what we were given, but we had to prove that the lengths were congruent. So it's important that if you were given length and you're switching to congruency, that you do switch back and forth. And so that's all the work I'm going to do. One of the things I do want to just kind of illustrate really quickly before I go is the difference in the transitive property and substitution. Now, these are two things that get really easily confused. So the transitive property is if A equals B and B equals C, then A equals C. So the transitive property requires that middleman. Here it's B. So if I know that 6 times 4 equals 24, and I also know that 24 equals 8 times 3, I look at these and I see that in the middle here, they're both equal to the same thing. So what I can do is kind of cut each one off at the equation, at the equal sign, bring both of those other sides down, and make this kind of like Frankenstein equation of 6 plus times 4 equals 8 times 3. And that is the transitive property. The transitive property allows you to say that if two things are equal to the same thing, then they're equal to each other. That is different from substitution. Substitution occurs like 5x minus 7. I say that x equals 3. Then I can write as 5 times 3, or 5 times 3 minus 7. 15 minus 7, that gives me 8. So here what I did was I just plugged that in. So I'm taking something out of one equation and into the other. So let's go back and look here and look where we had substitution. We had substitution right there on step 5. Now notice that this is substitution because there was no middleman. Here I know that AB plus BC equals AC, so I can plug that back in. I did not have that kind of middle grounds where two things are equal to the same thing. I had one thing equal to another, and so I can replace it wherever I find that. And that's the definition of substitution. Remember, it's if A equals B, then I get to put in A wherever I find B. So that is kind of the trick. If all you're doing is sitting there and is replacing one thing with another, that is substitution. If you are getting rid of that middle ground, that is the transitive property. Transitive property is very similar to what we did when talking about deductive reasoning and syllogism. If you live in Cottonwood, then you live in Arizona. If you live in Arizona, then you live in the United States. So using the law of syllogism, I get to sit there and go, if you live in the United States, then you live, or if you live in Cottonwood, then you live in the United States. So that's how that works. Yeah, you have two things which are equal to each other, so they must be equal, or two things equal to the same third thing. Right here, therefore, they must be equal to each other. And that's the law of syllogism, and that is the logical use of the transitive property. I hope this made sense, especially those of you who were absent today. Hope you guys return soon, and I hope this helped. If you have any questions, leave them in the comments below, or go ahead and give me an email. Thank you very much, and have a wonderful, wonderful evening.